Hi everyone, I hope you're okay, and I really hope that guys the videos we keep uploading are helping you out. Please note that guys this is the 11th video and the last video whereby I'm tackling the past exam question papers, only focusing on work, energy and power. Please do note that guys all the videos are uploaded. Just click the second link on the description below. It will direct you straight to the playlist whereby I'm answering all the 11 questions, and all of those questions guys, they are extracted from past exam question papers. And the first playlist is for those who still want to learn fundamental principles in work, energy and power. So do choose which playlist you want to go for and start working. Before I even start, please do share the video to your peers. A thing or two that I'll mention here might help them guys prepare for an upcoming test, or even prepare for an upcoming exam, or either help them just to elevate their knowledge in work, energy and power. So please do like if you're getting help, do comment, ask questions on the comment section, come up with alternative ways to answer these questions, and just help us guys to help to grow the channel, please, by just subscribing. Okay, we are told that an electric motor pulls a 20 kg crate from rest at point A up an inclined plane by means of a light inextensible rope. Um, the inclined plane makes an angle of 18 degrees with the horizontal. Then we have we are told that B, C, and D are points on the inclined plane, and the distance between A and C is just 15 meters as shown in the diagram below. Okay, we are then told that the motor exerts a constant force of 96.8 newtons parallel to the inclined plane on the rope. Okay, they're just telling us that the tension on the rope is that amount over there. Okay, and then we are told that a constant frictional force of 13.5 newtons acts on the crate as it moves up the inclined plane. First question, we are supposed to define a non-conservative force. Non-conservative forces are forces whose work done is path dependent. Are we together? Is path dependent, or you can simply say they are just forces whose work done is dependent on the direction of motion. Okay. 5.2, you are supposed to use the work energy principles to calculate the speed of the crate when it reaches point C. Okay, work energy principles. Now you can simply use the work energy theorem. It simply says work net is equal to the change in kinetic energy. Are you together? But what is by definition, work is the product of the force in question multiplied by the displacement in the direction of the force. Né? So in this case, I'll simply say F net delta x cos of theta. This will be equals to half mv squared final, or rather at position C, minus half mv squared at position A. That's the change in kinetic energy. Nah? For me to calculate over here, guys, the only thing I'm looking for is this guy over here. No, man. I'm looking for the velocity over there. Nah? So all I need to do is to first find my resultant force. Remember that, guys, F net is sum of all the forces in one direction, in one dimension. F net. If one would draw a free body diagram over here, the free body diagram would be like this. They will have the tension, which is the tension on the rope, normal force, and then frictional force, and then we have the components of gravity, Fg parallel as well as Fg perpendicular. Are you together? So the only force which are acting parallel to the direction of motion are these three. Né? So The only positive force, because I always take the direction of motion as positive, the only positive force we have is the tension. The others are negative because they are opposing the direction of motion. So this will be tension plus a negative kinetic friction and a negative Fg parallel together. So I'll simply have tension. I was given 96.8. Let me confirm. Yeah, 96.8, and then 13.5 for friction, minus 13.5. Fg parallel, guys, you will always find it by saying Fg parallel is equal to mg sine theta, right, together. So the mass of the object that is being pulled is 20 kg, 9.8 multiplied by the sine of 18 degrees. What do I get over there? 96.8 minus 13.5 minus 20 times 9.8 times sine of 18 degrees. I'll simply get my resultant force to be equals to, let me check I didn't do any mistake. Okay, I'll simply get my resultant force to be 22.73 newtons. 22.73 newtons, right? So now I can go and find the velocity of the block at position C. The value of my F net, I know that delta X is 15.6, that was a given. 15.6 cos of 0 degrees. This is equals to 22.73. On the other side, I'll have 1 over 2, still have a 20 vi squared minus. The block was being pulled from rest at position A. So since the block was pulled from rest, the velocity at A is 0 meters per second. When the velocity of an object is 0 meters per second, the kinetic energy of that object has to be 0 joules. That's all. Just substitute 0 over here. So on the left hand side, I'll say 22.73 multiplied by 15.6 multiplied by the cos of 0 degrees. On the left hand side, I'll simply have 354,588. This is equals to 10 v squared at position C. All together, if I divide both sides by 10, I'll simply get v squared to be equals to 35.4588. So the velocity at position C, just put the square root on both sides. You'll simply get 5.95 meters per second. 5.95 meters per second. So that's the speed or the velocity. 5.95 meters per second. Yeah, they wanted the speed. So direction does not matter. Okay, now they want us to find the minimum average power dissipated by the electric motor to pull the crate from point A to C. We can simply use the formula that says power is equals to the force in question multiplied by the average velocity. I know that the tension is 96.8 tension on the rope, and then the average velocity, we'll simply say take initial velocity plus the final velocity all over 2. then that will give us the average power. 96.8 multiplied by 0 plus 5.95 all over 2. So our average power, that's 287.9898 watts. Alright, together. So this is the average power this is the average power dissipated by the electric motor to pull the crate from point A to C. 287.98 watts. Okay, and then we are told that when the crate reaches point C, the rope breaks. Breaks the crate. Okay, it breaks, and then the crate continues to move up the inclined plane and come to a stop at position D, and then slide down past position B. Okay, we must draw a free body diagram draw the free body diagram for the crate as it slides down past position B. Okay, when the crate is sliding down, guys, our free body diagram will no longer be like this. There will be changes. Okay, let me just redraw it. It's fine. Our free body diagram will be like this. This is our crate. The component of gravity will be pulling it down. Gravity parallel. It's always paired with FG, perpendicular, and then we do have our normal force, F normal, and our friction. Right, together. You can draw your free body diagram like this, or you can simply draw it like this. You don't have to use the component, you can just use the gravitational force itself, weight, and then obviously you have kinetic friction, which opposes the motion of the object, and then you have normal force, which is perpendicular to the surface. Right, you'll get your full 3 marks if you draw any of the 3 free body diagrams, but if you label your forces like I did, you will get 0. You must write F normal, F friction, F normal, F friction, weight. These ones you can leave them like this, it will be fine. Okay, and then now I'm supposed to draw a velocity time graph for the entire motion of the crate, starting from point A until it passes point B. Until it passes point P again on its motion down the incline. So our velocity time graph will be something like this. The crate started from rest. It went up to a velocity of 5.95 meters per second. Are you together? And then when the velocity was 5.95 meters per second, the rope breaks. Are you together? And then the velocity will still continuing moving up, but its velocity will be decreasing until it becomes 0 at a stop, and then it will start moving again in the negative direction. Are you scared? So this will be point A, point C, and this is point D. Are you together? And then now it's moving down the incline whenever it's there. We must write the heading velocity time graph. Then do write this is the time in seconds time, and then we have the change in velocity in meters per second. Yeah, that's how, guys, we're supposed to write or rather tackle this question over here. I hope, guys, the video helped you out. Né? Please note that, guys, more videos with regards to physical science are coming. Just stay tuned. Thank you.